Architecture, at its very heart, is the art and science of designing buildings and other physical structures. It's far more than just putting up four walls and a roof. It's about creating spaces where life happens. Think about your own home, your school, the local library, or even the bus shelter you stand under on a rainy day. Each of these was designed by someone with a purpose in mind. They are the backdrop to our daily lives, quietly shaping our experiences, our moods, and our interactions with one another. Architecture isn't just for grand cathedrals or towering skyscrapers. It's in the everyday, the ordinary. It's the thoughtful arrangement of space to make our lives better, safer, and more enjoyable. But imagine a world without it. We wouldn't just be without shelter. We'd be without places that inspire us, comfort us, or help us work more efficiently. A well-designed hospital can genuinely help patients recover faster by providing natural light and calming views. A school with bright, open classrooms can foster a more engaging learning environment for children. A home that is designed to capture the morning sun can lift your spirits every single day. Good architecture addresses our fundamental human needs for shelter, security, community. Great architecture goes a step further. It elevates the human experience and speaks to our aspirations. Consider the difference between a simple, functional box and a building that truly sings. One simply serves a purpose, while the other creates a memory. So, what exactly is theory in architecture? It sounds rather academic and complicated, doesn't it? But really, it's just the collection of ideas, principles, beliefs that guide an architect's decisions. It's the why behind the what. If a building is the final dish, then architectural theory is the recipe book, full of different approaches and philosophies. It's not just about aesthetics, what looks nice, but about how buildings should function, how they should relate to their surroundings, what they should mean to the people who use them. Theory is the intellectual framework that helps an architect move from a blank piece of paper to a coherent, meaningful design, ensuring the building is more than just a random assembly of materials. Think of it like this. Anyone can stack bricks, but an architect guided by theory thinks about why they are stacking them in a particular way. Every building, from the humblest shed to the most ambitious skyscraper, begins its life as a simple idea, a spark in someone's mind. This initial stage, often called the brief or programming phase, is all about asking questions. What is this building for? Who will use it? What do they need it to do? Once the brief is clear, the architect enters the schematic design phase. This is where the magic really begins. Intense creativity, exploration, and, quite often, a lot of crumpled up paper. The architect will produce a flurry of rough sketches, bubble diagrams, and simple models. Following this creative explosion, the project moves into design development. Here, the chosen schematic design is fleshed out with more detail. It's a collaborative phase, often involving discussions with engineers and other consultants to ensure the design is not just beautiful, but also buildable, safe, and compliant with all necessary regulations. In the theater of construction, there are three principal actors whose roles are distinct yet completely intertwined: the client, the architect, and the builder. The client is the person or group with the dream and the resources. They are the instigator of the entire project. The client's most important job is to articulate their needs, desires, and budget as clearly as possible. The architect is the visionary and the translator. Their role is to take the client's abstract dreams and transform them into a coherent, buildable design. They are part artist, part scientist, and part project manager. They act as the client's primary advocate and are the creative conductor of the entire orchestra. The builder, or contractor, is the master craftsperson who turns the architect's detailed plans into physical reality. They coordinate subcontractors, source materials, and their expertise lies in logistics, craftsmanship, and construction practicalities. A successful project depends on strong, collaborative relationship between all three, forming a classic triangle of collaboration. Architectural drawings are the universal language of construction. They are the primary means by which an architect communicates their complex three-dimensional vision to the client, planning authorities, and construction team. These are precise, technical documents that convey huge amounts of information. Understanding the main types of drawings, plans, sections, elevations, is key to unlocking the architect's intent. The most common drawing is the plan. A plan is essentially a bird's-eye view of a building, but with the roof magically removed so you can see the layout inside. It shows the arrangement of rooms, position of walls, doors, windows, and placement of furniture or fixtures. Next up is the section. A section drawing is what you would see if you sliced through a building vertically. like cutting into a layer cake. It reveals the internal construction of the building from top to bottom. A section shows the height of rooms, thickness of floors and walls, shape of the roof, and how different levels connect. Finally, we have the elevation. An elevation is a straight-on view of one of the building's exterior faces. A typical set includes 4 elevations: north, south, east, west. These show what the building will look like from outside. Together, plans, sections, and elevations provide a complete, multifaceted picture of the design. Over 2,000 years ago, a Roman architect named Marcus Vitruvius Pollio wrote a treatise called De Architectura. In this work, he laid out what he believed were the 3 essential qualities that every good building must possess. These 3 principles, utilitas, firmitas, venustas, have resonated through centuries and remain as relevant today as they were in the age of Caesar. The first pillar is utilitas, which translates to utility or usefulness. This principle states that a building must be functional and serve its purpose well. This seems obvious, but it's surprisingly easy to get wrong. A house with a beautiful living room but a cramped, poorly laid out kitchen fails on utilitas. Utilitas is about the practical, human-centered aspects of design: good flow, sensible layout, accessibility, comfort. The second pillar is firmitas, meaning firmness or strength. This is the principle of structural integrity and durability. A building must stand up robustly and remain in good condition for a long time, withstanding forces of gravity, wind, and time. Firmitas ensures the building is safe, secure, and built to last. It's inseparable from architecture. The third pillar is venustas, which means beauty or delight. This is the aesthetic dimension of architecture. Vitruvius argued that a building should not only be useful and strong, but also visually pleasing and uplifting to the human spirit. Venustas creates spaces that delight through pleasing proportions, harmonious composition, thoughtful materials, and skillful play of light. Truly great architecture balances all 3 pillars in perfect harmony. The practice of architectural drawing is nearly as old as architecture itself. Ancient civilizations couldn't have built their magnificent temples without some form of planning. The oldest known plan is a 4,000-year-old clay tablet from Mesopotamia. Early plans were incised on stone, clay, or drawn on papyrus. For centuries, drawing was a craft passed down through guilds of master builders who often kept their techniques secret. The Renaissance marked a major turning point. Brunelleschi and Alberti rediscovered the principles of linear perspective. This allowed creation of realistic, 3-dimensional representations on 2-dimensional surfaces. This was a revolution. For the first time, architects could show clients what buildings would look like before construction. The drawing became a tool of persuasion and artistic exploration. The Industrial Revolution brought new printing techniques like blueprints, enabling mass reproduction and greater coordination on large-scale projects. Today, we're in another revolution, the digital age. Drafting boards have been replaced by computer-aided design software. Building information modeling allows unprecedented detail, coordination, and analysis, transforming how architects design and collaborate. Every building has a skeleton, an unseen framework that holds it up against gravity. This is its structural system. While we focus on visible surfaces, it is structure that makes it all possible. The choice of structural system is one of the most fundamental decisions an architect makes, as it profoundly influences the building's form, appearance, and the character of spaces within. Think about the difference between a traditional log cabin and a soaring Gothic cathedral. The log cabin uses simple load-bearing walls, where solid walls carry the roof weight. This results in smaller rooms and limited window openings. The cathedral uses a sophisticated frame system of pointed arches, ribbed vaults, and flying buttresses. In modern architecture, steel and reinforced concrete frames revolutionized what was possible, allowing wide-open, flexible spaces. A steel frame works like a skeleton, with columns and beams carrying loads. This separation of structure from enclosure led to curtain walls and open-plan living. There is constant dialogue between design ambitions and structural laws. In every great building, structural system and architectural design are seamlessly woven together, creating unified wholes that are strong, useful, and beautiful, perfect embodiments of Vitruvius's enduring ideals.